inshallah lecture number 9. Inshallah, bi'idhnillah, next Monday, no, Tuesday, sorry, we'll take lecture number 10. So that's almost we are done with the course. We have only one lecture left, and then we'll see if we can make a revision, inshallah. So let's go to lecture number 9. Lecture 9 talks mainly about graphics. Okay, talks mainly about graph. Graph, when we talk about graph, it's actually similar to trees. Graph, trees. So, for example, you might say or want to represent cities. So you will say that is Riyadh. Okay, that is Riyadh. That is Dammam. Screen is clear. Can you see it clearly? Paintbrush?
Yes.
Mumtaz. Okay, and that is Jeddah. So now you are representing cities as graph. So now there is a way from Jeddah to Riyadh, مثلا, for example, that will take, let's say, 9 hours. From Riyadh, it could be kilometers also. Okay, you can say 900 kilometers, for example. Okay, and then from Riyadh, there is also a way that will take 4 hours. That will take 4 hours. Now, there are more cities. Okay, we have Ahsa, for example. We have Ha'il, for example, and we have Medina, for example, and so on. So you will connect between these cities. So that what is meant by graph. That is what is meant by graph. And we'll come, inshallah, to see representation. We will see how we can search or read in another way. And we'll look at 2 very important algorithms, digestra and crosscut. Digestra and crosscut. So let's, bismillah, start. Anyone heard about that problem, the 7 bridges of Königsberg? حد مر عليه هذه القصة والنكتة أو يسموها اللغز عفوا؟ No. None? None? Fine. Let's see. ما في مشكلة. It's okay. Okay, let's see. Now, أولاً, Leonard Euler, okay, is a scientist, and that's his achievements, that's his CV. What actually drew my attention is the following. He became a professor of physics at 23. Can you imagine that? So he is teaching in a university when he was 23. And the professor of mathematics at 26. So now he is mastering 2 majors, physics and mathematics, and so on, and so on. One more thing, his life's work of 800, can you imagine that number? 886 books and papers, researches. 886 books and papers. طبعا is a very great achievement regardless of anything. Okay, now, while he's working, he got to hear of the problem of the 7 bridges of Königsberg. The river Breda, the river, okay, اسمه Breda, ran through the town and divided it into 4 lands. Nahar divided the city into 4 lands. 1 or 4 areas, one of which was an island in the middle, green one, okay? The river was spanned by 7 bridges. So they built bridges. So you can go from one area to another area. And the people of the town tried to walk around the center that crossed all 7 once and only one. This is like if you are playing a game, so they want you to go through all the bridges without repeating crossing a bridge again. هذه ببساطة. It's like a game. Like at the end, that would draw the attention of this scientist, Euler. And he started thinking about graphs, about the theories, properties of the graphs. هذه ببساطة الidea. So now, can you use your worksheet to try and find the route around the center? Can you go and cross اللي هي red heading bridges, the red ones? So you have 7 bridges. 1, 2, 3, 4, 5, 6, 7. So can you go through all of them without crossing one twice? So it has to be one and only one, once and only once. That's the starting of the idea. Now, see, he started to think about that as vertices. Okay, so now that one is vertex, that one is. So how can I go from 1, 2, for example, 3, 4, 5, 6. So when he reached here, there's a question mark that, okay, now he still need to go and cross that one. So there is a problem. The only way is come back again. That is twice, not acceptable. Come here, twice, not acceptable. Come here, twice, not acceptable. Come here, twice, not acceptable, and so on. So that is the idea or the background of the Euler theories and graphs and so on. Okay, now some of the point that he came to reach, which is what is called an odd and even. Odd and even. So what do you mean by odd and even? During his investigation, studying the case, Euler defined an even vertex and an odd vertex. Even, odd. So what do you mean? What did he mean by that one? An odd vertex has an odd number of arcs, which is that is going from that vertex. Okay, an odd vertex has an odd number of arcs connected to it. So now that one, odd. Why is it odd? We have 1, 2, 3. So it's considered odd vertex. That one is even because we have 1 and 2, no more. So that is even, and so on, and so on. Connected and even has an even number of arcs connected to it. So he started in that way. So if a graph has Euler, then the number of odd degrees vertices is either 0 or 2. We'll come to it, inshallah. Okay, so that's basically the idea of the starting of the graph theories, Okay. يا فيصل يا فيصل. Okay, so an Euler circuit in a graph is a simple circuit containing every edge of the graph. So if you have a circuit, okay, it means that it contains all the edges of the graph. Edges, real arcs, okay, that is connecting. That is an edge. That is an edge. Okay, so that is one of the points he talked about. And Euler path in a graph is a simple path containing also every edge of the graph. That's what another point he reached to. So he came up with theorem number 1. A finite graph has an Euler circuit. Euler circuit, which is, as we said, simple circuit containing every edge of the graph. So it will take all the edges. And if and only if it is connected and all vertices have an even degree. Even degree. Theory number 2, finite graph has an Euler path, but not circuit. It has a path, but not circuit. If and only if it is connected and exactly two vertices have odd degrees. Two vertices have odd degrees. That's one of the points also that he reached to. Now, let's go one more step. Now, graph is an order pair, which means that a graph contains or equal to vertices and edges, where V is a finite set of elements. So that is vertex. That is vertex. That is vertex. And it can be representing anything. As we saw, it can be cities. It can be countries. It can be buildings. So if you have, for example, a company and it has buildings, so you can draw a graph for that one. And E, which is set of subsets of V. Example, 1, 2, 3. So those are the V, 1, 2, 3. Now, what is the relation between them? So we have a relation between 1 and 2, 3 and 2, 1 and 3, 1 and 2, 1 and 3, 2 and 3, or 3 and 2, it doesn't matter. That's starting of that one. Then we have some concepts there. One of them is no loops. Or loops, depends. What do you mean by loops? Loops here means that you have a connection, of a vertex to itself. So it's going to the same vertex. The edge going to the same, that we call it loop. Or we might have a multiple edges. Multiple edges means there are two ways from two vertices, or two edges from two vertices. هذه يعني مهمة جدا, because we will come later on to one of the algorithms that you must eliminate that or those ones. Directed graph. So we have directed, we have undirected. Directed means if there is a connection between two vertices, there is an edge. So is it directed? Means 1 to 3. Here is must. You cannot say 3 to 1. 1, 3. So it is directed. So you can go from 1 to 3, but you cannot go from 3 to 1. That one, undirected. You can say 1, 2, or you can say 2, 1. It's okay. Simple. Questions so far? Any questions so far? Everything is all right? Okay. Now, end vertices means that the end points of an edge. Edge is the way, is the path, is the arc. So that is A, for example. So what are the end points of A? V and U. What is the end of D? V and W. What is the end points of E? X and W, and so on. So U and V are the end points of A. That is a terminology. Edges, incidents. on a vertex. Okay, we talk here about what are the edges of one vertex. For example, A, D, and B are incidents on V. That is V. So V, we have A, B, D. So طبعا doesn't matter the order هنا. Okay, so we have A, B, D, or A, D, B, or B, D, A. So those are incidents of V. طبعا it could be for sure shared by others. يعني A shared with you, since we have endpoints, so it is shared also with you. So what are the incidents of U, A, and C? Degree of vertex, X has degree 5. X has degree 5, that is X. So degree 5 means number of edges coming out of it. So we have 1, 2, 3, 4, 5. So that is degree 5. Parallel edges. Parallel edges means H. Example, طبعا H and I are parallel. So we have H, we have I, that considered parallel. Self loop, we said that before. J is self loop. It means there is J or Z هذه قصدهم. لو هذا loop anyway. That is a loop. أعتقد هنا غلطانين. So we have a loop. J قصده هو حسبها بال اللهم صل على النبي الإدج. Okay, so J, an edge J is a loop of Z. Is a loop. So going to the same place. So J is a self loop. Adjacent vertices, U and V are adjacent, mean neighbors next to each other. U and V. Edges G and F are adjacent. G and F. It means share the same endpoints. Share the same endpoints. So Y, X, Y, W. Okay, path is sequence of alternating vertices and edges. So I need to go from V to Y. How can I go there? So you might go through several edges, several vertices. Okay, so you will begin with a vertex, end with another vertex. Each edge is preceded and followed by its endpoints. And that's the main concern of our lecture today. Simple path. Path such that all its vertices are edges are distinct. بمعنى مثلا B1 path number 1 V B X H Z. So it is a simple path. Path 2 U C W E X G Y F W. So now repeat it. So you went to somewhere and come back to it again. So that is what is called not simple path. Probably very general terminologies. It's good to know it in case if there are some questions. Properties. Degree of V. We talked about the degree. Degree of V equal to M. What is M? N is number of vertices. M is number of edges. N is order of the graph. M is the size of the graph. Okay, so in order to get degree of something, we have a probability now. Each edge is counted twice طبعا هنا, وبالتالي that is the one that could be proved. And probability number 2 is an undirected graph with no self loops and no multiple edges. M will be less than or equal n minus 1, 2. So M again is the number of edges and n is the number of vertices. So To know the numbers, you have to substitute how many vertices do you have, how many edges do you have. طبعا هو معطيكم example هنا. example عندنا n equal 4 1 2 3 4 و m equal 6 1 2 3 okay 4 5 6. Okay, this is important. Now, how to represent graph? As I told you, depends on the case. Depends on the case. For example, now I have, in my case, جدة رياض دمام مدينة حائل okay رياض then دمام أحساء and so on. Okay, and so on. So, how can I represent that? I can represent that as a matrix. And we see that all the time. So you might say Riyadh, Riyadh. Jeddah, Jeddah. Dammam, Dammam. Now you will start building the matrix as follows. You will say from Riyadh to Riyadh, what is the distance? 0. From Jeddah to Jeddah, what is the distance? Still 0. From Dammam to Dammam, 0. And so on. Okay, and even if you have 1 or 2 or 5 or whatsoever cities, it will keep saying because no self, so it will be 0. Now, from Riyadh to Jeddah, you said here 9. So you will say 9 hours, 900 kilometers, 9 days, 9 weeks, 9 whatsoever. So, but it's from R to J is 9. And since it is the same, so also from J to R is 9. This is the way you will represent a graph as a matrix. Let's go back. Okay. So the way is to represent a graph, that graph U, V, W, Z. These are the edges, E, G, F, H. It could be numbers, it could be anything you want. Now, to do that, adjacency, matrix, U, V, W, Z. U, V, W, Z. That is 0, 1, 2, 3. So again, 0, 1, 2, 3 is U, V, W, Z. So U, V, W, Z, U, V, W, Z. And now, is there anything from 0 to 0? U to U? No, no loop. There is no loop. So it is 0. From V, which is 1, to V, which is 1, 0. From W, which is 2, to W, which is 2, 0. From 3 to 3, 0. So that is diagonal zeros, since there is no path or no loop to this. Just imagine if there is a loop, then there will be a number. Next, from 0 to 1, 0 is U, 1 is V. So is there any path between U and V? Yes, there is. So that is 1. From 0 to 2, 0 is U, 2 is W. Is there any path, any way, any edge between U and W? Yes, U, W. So that is U, W is 1. To Z, nothing. So that is the way you represent that. Or you can do it as the names, EG, EG. So it could be 1, 1 or EG. 1, 1 means yes, there is. True. 0, 0, it means false. No. So this one is representing that one, which is actually that. Questions so far? Questions so far? Okay. How about that one? Incidence matrix. We just talk about the incidence. So incidence matrix, that is the representation of the incidence matrix. Anyone can think of how we got 1 1 and 0 0 1 0 1 0 0 1 1 1 0 0 0 1?
There one. If connected 1, if empty 0.
Okay, empty 0. Now look what it says here. 1 if a vertex. تمام, vertex I belongs to the edge J. الآن مثلا for example U, what are the edges? E and G, so it belongs to you. Okay, if vertex I, طبعا I that's general. Okay, you can substitute it by anything, U مثلا أو Z. So now if vertex I in my example now U belongs to the edge J. J also, it could be anything. So in my case now, E. So U, E has a relation, yes. So U and E, yes, there is. U and G, yes, there is. How about U and H? Nothing. So U and H is 0. U and F is 0. And F or H is not belonging to that one. أو العكس ده not belonging. So that's how also. So incidence اللي هي ارجع للتعريف هنا نحن قرأناها من شوية. Yeah, edges incident on a vertex A, D, B are incident of V. So that is V. What are the incidents? A, B, D. So now if there is a representation, a matrix, it will be for those 1 1 1. هذه ببساطة الidea of that one. Is it clear? So now طبعا generally if there is an exam they will give you مثلا the graph and ask you to build the matrix of adjacency matrix or incidence matrix. Questions? Any questions? So far so good. ممتاز. Next. Now also you can do the following, same idea. Okay, now edge list structure, augmented vertex objects, integer index associated with the vertex. So you will have now a 2 array واضحة جدا هنا, and you will start also matching. Depends, is it adjacency or incidence? Is it yes, true, false? Okay, or you supply or provide actual values. So it could be, as we said in cities, actual number of kilometers, actual number of hours that will take me from city to another city. It could be water network. Okay, now you will connect between districts in a city. So you will say that there is a pipe which is 5 kilometers from 2. So it's connecting between these 2 and so on and so on. So that is the idea of that one. ADT. أحد يتذكر what does it mean? ADT. ADT. Graph ADT. You remember ADT? We talked about Q ADT, stack ADT.
Abstract data type.
Thank you very much. Okay, so that will give you what are the main نحن نقول functions or methods, okay, that can be applied to the data. So vertex count, for example, returns the number of vertices of a graph. Now you remember في stack and queue we have the bob والenqueue والbush is empty, تمام, والlength إلى آخره. So those are sort number of methods that can be applied. Now تحبوا ناخذ بريك 10 minutes نصلي ونرجع, ولا ناخذ واحدة ونرجع على راحته إذا بدري؟ أنا عندنا أذن أعتقد في جدة خلاص. ولا ناخذها في منتصف المحاضرة على راحتكم؟ طيب ناخذ واحدة عشان تقدروا بعدين تفكروا فيها. If you have a graph like that, A, B, C, D, E, F, I think you still remember when we talked about when we said we have مثلا A, then we have B and C, binary tree. Then from B we have D and E. From C we will have F. خلاص كفاية كده. Now, do you remember how did we read that tree? Anyone can remember how did we read or traversed or visited that one? أكيد هتجيكم في الكويز هذه إذا ما already جاته.
Post order, in order, per order.
Thank you very much. Yes. Okay. Yes. So you can read it in anywhere. You might say, I will read it as مثلا root. Okay. Root, then left, then right. So that is pre-order. Or I will start with left, then root, then right. So that is in order. Or I can read it as left, then right, then root. That is post order. With the same way, we can do that with graph, but with little difference here. We have two famous ways to do that. Breadth, first search, and depth, first search. So you might be given a graph and they will ask you to read it as a depth or read it as breadth. Now, very simple, very easy, inshallah, بإذن الله تعالى. And just think, what is the difference between the two? Only, that's all what you need. What is the difference between the two? Now, breadth. First of all, in breadth, you use Q. In the depth, you will use stack. هذا number one. Okay. Now, طبعا doesn't matter now if you have very small simple graph or very complicated graph. If you understand the idea, it will be so easy, inshallah. Now, let's look at the three rules. First of one, you will decide what is my initial step. You can generally, you can start from any vertex you want. Any. Okay, so you can start from A, you can start from B, you can start from E, but if you selected one of the vertices, stick with it. Because you cannot change. You cannot change until you finish. So that's why, put it in your mind what I'm saying now. That's why we might have several solutions. Like that one. Here, maybe if they say just without telling you that one, okay, they will tell you just traverse, visit, read, search that tree. So Ahmed might say root, left, right, pre-order. So he will start from the root. So he will say that A is the first one. Huda will say no, I will use L, root, R. So what is the first one for Huda? That for Ahmed. What is the one for Huda? Since you will start with L. Anyone? See if you remember or not. Okay, so now that is the root. Is there a left? Yes, so I cannot take A. There is a left. Now, the left became a root. Actually, that is a subtree. That is the subtree. So I cannot take it. I have to go to the left. So that is the left. So start from now. B or A or D? Because B, it is a left of A, that's true, but when I went to the left, now I have another subtree. So I have to look, is it the one I'm looking for? No, you will start from the D. So Huda will start from D. Nasser. Nasser said, I will go with L, R, and root. So now what is the first one for Nasser, Mr. Nasser? Be careful. Agree, all of you? Let's see. Nasser said, I will take post order. So post order means that is the root. So is there left? Yes. So left means there is another subtree. Is there a left? Yes, D. Is there any more? No. So I will take it, so it will be also D. So what does it mean here? We have more than one answer. The same. You might have more than one answer at number one. But it will be correct if you followed the rules. If you followed the rules. Okay, if you followed the rules. Rule number one. Rule number one. As we said, you will select the initial starting from where you will start at number one. Number two, visit the unadjacent, unvisited, this is very important, unvisited vertex. Mark it as visited. So you will say that one is visited. You put any sign. Display it. Display it. Insert it in Q. I will explain it practically now. Okay. Rule number two. If no adjacent vertex is found, remove the vertex from the Q. Number three, repeat rule number one and rule number two. So you will repeat one and two until what? Q is empty. Q is empty. BFS on a graph with n vertices and m edges takes O, big O of n plus m. Let's see. Now, let's say that we decided to start from A. I will go parallel because here in the PowerPoint, maybe the one who developed that one, he made some shortcuts there. Now there is a Q. Okay, enough, and that is my Q. That is the first element. That is the last. In Q, all of us know. First in, first out. So, and in Q, I will adding will be from the end. That is the Q. So all the time you will add from the end, add from the end. Now, we selected A. We selected A. So that is the first one will enter to the Q. That is B, F, S, Now, from A, طبعا لاحظوا هذه it means visited, هذا sign, visited vertex. When you make a thick border, it means visited. Unthick, not visited, or اللي هي thin not visited. So now, what are the adjacent vertices? We have B, C, D. So you have to visit them all. Again, you have to visit them all. So now, from A, you will go to the B, you will go to the C, you will go to the D. So you will add them. B, C, D. If you take it step by step, it will show you that when I add B, it will be there. Someone will tell me now, where is A? I will tell you now. Okay, A visited B, so now you added B. Visited C, so you will add C. Visited D, you will add D. It's a queue. So every time you will add from the end. A, the one who did that, he just made a quick shortcut here. A quick shortcut. It's supposed to be A, B, C, D, but it will not affect. I'll tell you why. I will tell you why. Because now A, that is I am here right now. I selected A. So I visited all the adjacents B, U, C, U, D. B, C, U, D. طبعا F و E no relation. ما في أي edge that goes to E or F. So now I visited all. طبعا it should be added, by the way. B, C, D. Now I visited all the neighbors of A. It will be now DQ out. So no A now. That's why they were just BCD. It means that since you started with A, you visited all the neighbors, so now it will be NQ. What is next now? If I NQ, remove, delete, out. So what is the next? Should we go out?
B.
Thank you. Since you are using Q, again بس أنا أبغى أأكد على القصة هذه. Added to the Q. So we are using Q. So added to the Q. Since we finished all the adjacent vertices, remove A. So now forget about A. My Q contains B, C, D. So I cannot deal with D because I cannot remove it unless I remove C. I cannot remove C or deal with it because I have to remove B first. So now we will go with B. What are the neighbors of B? Forget about A now. It's not in the queue anymore. B now. B our target in the queue. That is B. So what are the neighbors of B? You can see it now. A, C, and what? E. A, C, E. A already visited. C already visited. E not visited. So that will be the next. يعني no need to repeat. No need to say A and C again. It's already there in the two. No need to repeat. So now B will go to the E. So that is our next vertex. Will be added to the queue. Now, did we visit all the neighbors of B? Yes, we did. So now, can anyone tell me what is the next step? What is the next step? Can anyone tell me? I visited now all the neighbors of B, or let's say all the neighbors of B were visited. A visited, C visited, E visited. So what is the next? Anyone? Just guess.
We will remove B and then go to C.
Okay. So now we will remove B. That is true because now we are done with B and the target now is C. Okay, the target is C. See, خلاص. I removed B. The target is C. In my, I will remove B. طبعا already finished with B. Now I am in C. Same idea. That is C. C is connected to A, B, and. Now, the only one which is unvisited is F. So I have to add F. Right here, add it right here. طبعا, you will notice now that we visited all of them. هنا عفوا. Okay, خلاص, done with that one. So now you will start eliminating them one after one. Since you visited all of them, you will ask now yourself, C, no more, remove. D, no more. A, already mentioned, do C mentioned, do F, all of them, so it will be deleted. E, no more. So it will be deleted. F, no more. It will be deleted. So now that is the reading. A, B, C, D, E, F. Okay. A, B, C, D, E, F. Is it the only solution? Again, no. Someone will start from B. That's fine. From B, he will go to A, C, E. So now, totally different from this one. But you have to do the following. If you selected B, that's fine, but you have to visit the neighbors, Loma, A, C, E. You have to visit them. Now, you said BA, fine. When you remove B, because it is the first one actually, the next will be what? A. With the same idea, you will visit all the neighbors of A. B already visited. C already visited. Then you will go to the D. Add it to the queue. Add it to the queue. Add it to the queue. Then you will start remove them, remove until you finish. Questions? So don't worry how they draw that tree. يعني مثلا ممكن they will give you that one. For example, they said that is a graph. That is a graph. Which also look like what? A binary tree. With tree is a graph at the end. Okay, so now that is 1, 2, 3, 4, 5, 6, 7. Ask you to read it as a graph, as a breadth first. So someone will say, Dr.Shaikhan, I will start from 1. Excellent, no problem. So it will be 1. That is the first one. What are the neighbors of 1? Very clear. 2 and 3. I have to visit them. 2 and 3. Now, any more? 1? No. If I represent it as a queue, it will be the same. 1, 2, 3. So no more neighbors out. So where should I go? 2. Be careful. You selected 2. So you have now to take 2. 2. Is there neighbors? Yes. 4, 5. So you will say that is 4, that is 5. And again, it will be added here in the queue, 4 and 5. Any more neighbors? No, there is no. So 2 will be out. 3. You will go to the 3 now. What are the neighbors there? 6 and 7. So that is 6, that is 7. Any more for 3? No. Out. I will add 6 and 7 here. Any more for 3? No. You will go to the 4. That is 4. Any neighbors? No. Remove. What is next? 5. Any neighbors for 5? It's not connection by mistake. 5? No. Remove. What is next? 6. No, remove. 7. Nothing, remove. So that is the reading. Okay, so don't worry about how they draw it. Just worry about the concept. What is your initial value? And then just continue. طبعا لاحظوا هنا في كان example أنا يمكن مشيت عليه سريع. It seems complex. Actually, it is not. You will start from S. What are the neighbors? A, B, C. Any more? No. Remove. Remove S. So now you start with A. What are the neighbors of A? D. That's why it is 4. Any more? Yes. G. That's why. And so on. You will just keep reading them one after one until you reach to the last one. طبعا في example هنا لا خلينا go to the next one اللي هي depth first. Now look at the depth first. A, B, D, E, C. Same idea. You will select an initial value. Visit the adjacent and visited vertex. Mark it as visited, display it, now push it, stack. Push it and stack. Now, you will keep going. Okay, now, if you will start visiting not all the neighbors, not all the neighbors, you will visit only one and you will select it. It's up to you. Only one. From that one, طبعا it will be added, Bob, to the stack. Okay? Afwan, sorry. It will be pushed on the stack. And if there is no adjacent, if there is, you will select one. If there is, you will select one. But if there is no, it will be bobbed. Bob, you know that in a stack, we say bob, it means delete, remove. Only one. And from that one, you will repeat the rules. Let's look at almost the same example. Now, you have A, B, C, D, E. That is the connection. Now, we need to read it as depth, not breadth. Let's put it here, so it will be much easier, inshallah. We will have a stack. And so on. Okay, that is stack. We decided to start from A. So A now right here. Again, in the stack, we know that first in, last out. This is very important. That's number one. Number two, from A, you have B, D, E. You select. I will select B. So B will be طبعا هنا A حتكون وهنا B. B will be added to the stack. Should I deal with D and E? No, forget about them. You selected B, forget the rest. Forget the rest. Now, from B, because that is your target, from B, you will select one. Even if you have more than one, you will select only one. So, A already visited. So, the only option for me is C. So, I will select C. So, C now will be selected. It will be added to the stack. Now, it's getting more sophisticated now because A will not be left deleted unless I get rid of B and C. So now it's A, B, C. Now from C, you have A, you have also B, you have D, you have E. Again, you have to select one. You have to select one. Now A is already visited, B already visited. طبعا هو talking here. Okay. After that one, A already visited, B already visited. So now, what is left? D and E. You can select any one of them, by the way. I will select D. So to follow the same selection of the slide. So I will select D. So now D will be added right here. D will be added right here. Anything left? No, that's it. I cannot visit E. I cannot visit E. It's only one. Now, from D, that is my target. That is my target. From D, which vertices can I visit? I can visit A, already there. طبعا يمكن هنا أوضح لكم. D, visit A, already done, visited. Can visit C, already visited. Anything else? No, nothing. Bob D, else. Mali. Imagine that it's not there. So now it's empty. So now I have CBA. CBA. What is next? C. Now C visited D and we said forget E. Now I can visit E. So now I will visit E this time. But if there is anything connected to D, I have to go to that one. But there is nothing. So I will come back now to C. I will visit E. So now E is my target. So E will come here. Because now that one is empty, so it is not. Okay. Now, since I added E, كأنه لا دي deleted خلاص. Now it is ECBA. So now, since I deleted D, now E is the new target تبعي. E, is there any unvisited one? بغض النظر من هنا visited. Okay, C is visited. So now I will remove E. My target is C. My target is C. C visited all. Visited all, yes, visited. D will A and so on. So now I will remove C. B visited all, yes, visited all. So removing B. Now we are back to the A. A visited all, yes. So A, B, C, D, E is the reading of that one. A, B, C, D, E is the reading of that one. Okay, now let me give you little practice. We'll take a break, 10 minutes, pray dhuhr, and come back. Can we solve, without looking at the slides, please, okay, without looking at the slides, can we solve this one as BFS? And we solve it as BFS, breadth. In the new example, they just removed F, ما كان في F, okay? ما كان في F في الدepth. So we want to solve that one as DFS. Okay, try it. We will try it together after a break, inshallah. Any questions before we go to? Any question? Fine. So please solve it and we'll come back, inshallah. 10 minutes, inshallah. Assalamu alaikum. BFS. Not yet. اليوم مرة هادين بزيادة ما أعرف إيش السر. Hello. No luck. Say no luck. I will explain it to you, or leave it to next meeting. واحد اثنين. Hello.
الو
هلا والله. فما حليتوها عادي ترى يعني اوكي بس let me know. So there is a problem.
حاولت دكتور.
يلا انا بالمحاولة.
وانا معي
ايوه.
الستاك من from the last to the first A B C E D F.
عيدها ثاني معلش.
A B C E D F.
E كده دي.
ايوه
F.
D.
ممتاز.
This is the stack.
stack. اوكي ما في مشكلة. طيب now we will solve it. I will solve it in different way. Then I need you to check your answer. It could be correct. It could be correct. Okay. I cannot say now it's wrong or no, but I will solve it in my way. Now, BFS, we said it uses Q. A DFS will use stack. So now this is your solution. خلاص. We'll leave it like that. Now we will DFS, depth. Okay. هناك breadth. Okay. That is a stack. إلى آخره. Now, I will select A. So that is A. It will be added to the stack. Then from A, I can select B. I can select C. I can select D. I will select B. So that is B. طبعا you did the same. I will select B. So B will be added to the stack. Now, forget about C and D. Since you visited one, you will continue with that one. So forget about C or D. Okay, forget about C or D. Now, I am right here in the B. I can visit A, already visited, so forget about it. I can visit C, unvisited, so I can do that. I can visit E, unvisited, I can do that. Again, it's up to you, you decide. I will select C. So until now, mine and yours are the same. I selected C. C will be added to the stack. Now, since you selected C, you cannot go to the E. In the same way, so this is a concept. When you selected A and you visited B, so you cannot visit C and D. You have to start from B. So by luck, C is also connected to B. So you went to the C. When I went also to C. So it seems, ABC, you came A, B, then AC. No, it's actually AB, then BC. شوف my brother اللي جاوب على السؤال هذا. So now I cannot go to E. So here is you have a problem. I cannot go to the E. So I will go to the C. From the C, I will select one. Now, C. You have E. You can visit it? Yes. You can visit B? Yes. You can visit A? Yes. You can visit F? Yes. You can visit D? Yes. Now, A and B already visited, so forget about them. So you have the options of E, F, and D. I will select D. طبعا I know. You selected E. No, I will select D. Okay, so now my target is D. So it will be added to the stack. So now there is a difference between me and D. I selected D. Now from D, I can visit A, I can visit C, I can visit F. A and C already visited, so the only one left is what? F. So I will go to the F. So F is added. Now, from F, I have to visit the others. So what are the others? Either D or C. C already visited, D already visited, so nothing there. So F will be what? Bob. No more. Since it is Bob, I need to go to the next. Now the next depends on my selection. It depends on your selection. I selected D, so that will be my target. You selected something else, it will be depends on your selection. So now I will go back to the D. From D, A already visited, C visited, F visited. So again, Bob, remove, no more. Now, depends on your selection. And in my case, I will go to the C. So C is my target now. Now, A already visited, B visited, D visited, F visited. So what is left? E. So now I will take E. E will be added right here. You know, هذه empty وهذه empty خلاص. From E, I can visit B or C, but all of them are already done. So remove. Then C. Then C. All of them also visited. Remove. Then B. Visited all. Remove. A. Remove. So that is my reading. Now, I am not saying yours is wrong. No. But follow what I did, and you will see it is correct or not. Leave it to you. Okay, so that's basically the idea. If doing, now I have two solutions, okay, DFS and BFS, the same tree. When we did it in BFS, it was A, B, C, D, E, F. And I followed the same way, so it gives me A, B, C, D, F, E. A, B, C, D, F, E. Questions? But again, yours, it could be also, because we can have more than one solution. But you have to follow the concept. Questions? Any questions? Digester algorithm. Digester algorithm finds the shortest path between particular pair of vertices in a weighted directed graph with non-negative. Non-negative. Non-negative is a drawback that might cause problems. And negative, I'm talking, okay? So we deal with non-negative edge weights. So it solves the one vertex shortest path problem. What is the shortest path to reach from place to another place? From vertex to another vertex. Basic algorithm concept, create a table of information about the currently known best way to reach each vertex distance previous vertex and improve it. So you will keep improve it. Don't take the first solution until you reach to the best solution. Because sometimes you might reach a solution, but you are still not finished. Finishing might keep the same solution, might give you a better solution. We'll see it, inshallah. Imagine that vertices represent cities like what we did. An example will work. Edge weights represents driving distances. It could be anything. It could be days, times أي حاجة okay between pairs of cities connected to a direct road إلى آخره. So digestural algorithm can be used to find the shortest route between one city and any other cities. For a connected edge with graph G, a source vertex U, okay, belongs to VG, so finds the minimum weight. You need to find the minimum. Solutions, this is general, I will explain it to you practically. Set S to phi, تمام, which will store vertices G, إلخ. Then you will, is very important, if you don't know the path, which is actually your initial case, so put them infinite. Then you will start make it better, اللي هي هذه better solution. So you will improve until it reaches the best solution. You will keep until you reach to the best solution. طبعا then repeat your traversing or moving or visiting or reading إلى آخره. Finally, for each V belongs to S, TV is the minimum weight of a path in G with a weight function. هنشوف مع بعض. Cities. We have a table that they talked about. يعني table, follow me with that one, but it will be much easier to follow what happens here. Oh, it's good to follow here. ما في مشكلة. Now, pick a vertex in a list with minimum distance. Now, basically, actually, you will start also before that one. What is your initial vertex? Initial vertex. So my initial vertex is A. So A to A is 0, nothing. A to A is 0. Now, from A, where can I go? The city. Okay, that is a city. So from A city, where can I go? I can go to B. It's another city. I can go to D. Notice here, there is infinite number, infinite, all of them. So now, from A to B, it will take 2 hours to reach there. 2 hours. So which one is smaller, 2 or infinite? The 2 is smaller. So now I will delete that one and just say 2. That one is the same. A to D. It will take 1. That is infinite. It all the time start with the smaller one. But now I'm saying that from A you can go to B and D. All the time start with the smaller one. So from A to D, that is 1. So that one supposed to be 1 instead of, because 1 is less than infinite. Is there any other places, any other cities I can go? No. So the next target is the smallest one is 1. So that from A to 1, that is 1. From A to B, that is 2. And that one is updated. Now, from A to B, that is 2. From A to D, that is 1. With the rest, still infinite. Still infinite. Question so far. If you understand this one, the rest is so easy. If you understood what I said, the rest very easy, inshallah. Questions? Yes, no? Any questions? ممتاز. اطمئن ان الامور يمكن يكون انا المايك مفصول ولا اي شيء ولا. Okay, so what is the next target? We have 1, we have 2. طبعا إنا supposed to go to the smaller. Okay, so we will select D. vertex in a list with the minimum distance D. So we have 2 and 1. So we'll select D. Now, D is a city, Dammam, مثلا. Let's say that. Okay. So now, from D, where can we go? Very clear. I can go to E. I can go to G. I can go to F. I can go to C. So from D, I can go to all of these cities. You will update now these numbers. D to E, 2. Okay? So now, that a mistake that might be committed, be careful. That mistake. Someone will say, as I did here, D, A to B, that is 2. So 2 is less than infinite loop or infinite number. So erase that one, put 2. So here is the same. D to E is 2. So 2 is less than infinite. Delete that one, put 2. Wrong. That is wrong. Be careful. Be careful. Here actually talk starting from A. Starting from A. So from A to B is 1. So now, when you go to the E, you have to calculate that one. It's like you are saying, I need to go from Abha to Dammam. Then I need to go from Abha to Eagle. Medina اسمها Eagle. So that will be, I have to travel to D first. So it will take 1. Then I have to travel to Eagle, that it will take 2. So 1 plus 2 is 3, which is here. Don't worry about that one. It's here already. So 1 plus 2 is 3. So now it will be up. 3 is less than infinite. So that will be 3. Same idea. I need to go to G because there is a way. So now it will be 1 plus 4, 5. 5 is less than infinite, so that's 1 will be replaced by 5. So now we have 3 and 5. Again, I can go to F also. 1 plus 8, 9. So that is infinite, so it is less than. So that will be updated. So now I have 3, 5, 9. Last. I can go to C also. I can go to the C. So now, to go to C, I will say 1 plus 2, which is 3. Which is 3. So that one is less than infinite. That one will be 3. So now my solution is 3, 5, 9. In another word, now let's make it simpler one. I need to travel from A to C. So the best or the shortest way is to go to the D. That will take 1 hour. Let's say that is an hour. Then I can go to the C. So now that is 3 hours. So from 3 means from A to C. That is the shortest path. So far so good. طبعا لاحظوا the table is updated. It was infinite, now it is 3. Infinite is 3. اللي هذه 3 and 3 updated. With the same for the 5 and 9 updated. 5 and 9 updated. That is Dijkstra algorithm. What is next? We have here 3, we have 9, we have 5. So we have 3 and 3. We can select any one of them. I will select that one. So now, if we select the next one, what will happen here? We have E. So where can I go from Eagle? The only place I can go is G. The only place I can go is G. So 3 plus 6, 9. Is it less than 5? No. No update. Be careful here. It has to be less. Okay, again. Now, that is smaller one. So I will select that one. So from E to G. 3 plus 6. From where the 3? From A. 1 plus 2. Then will be plus 6. So that is 9. 9 is less than 5. No update. طبعا explanation here very simple one. If I need to go to E, I need to go from A to G. I can go to D, then go to E, then go to G. It's acceptable. But there is a shorter path, which is go to D, but don't go to E. Go to G directly. So 1 plus 4 is 5. So why should I go to E, then go to the? Because we are looking for the shortest path. Clear? So no update here. It will remain 5. Now it is selected. What is next? C. So from C, I can go to F. I can go to A. طبعا 4 is less than 0. That is the starting value, so forget about it. Next, 3 and 8. Can I update? Now someone say already done. Yes, it's already done. From where? Done. When we said anyone remember? From D. It was from D because it was here. 1 plus 8, 9. It's already done. But now 9 from C, is it shorter? Yes. 3 plus 5 is 8. So it has to be updated. And already we did it from D. 1 plus 8, 9. Updated. طبعا no updating هنا نتكلم عن 5 هذه. So it will be updated. 3 plus 5. So now that is shorter. That is shorter. What else? What is left? From G. From G. طبعا هي كانت 8 من شوية. From G. If I go to F, 5 plus 1 is 6. 6 is less than 8, so it has to be updated. D is the last one. No more updates. خلاص. So that is the shortest path. Now, select any city as a target, starting from any city you want. You will discover that you have the shortest path. So I need to go from A to F. So I'll go to D, that is 1. Then I will go to G, that is plus 4. So now it is 5. From G, I will go to the F, that is plus 1. It is 6. So that is the shortest path from A city to F city. With the same for the rest. طبعا لاحظوا updated. updated. كانت infinite 9 9 9 then 8 then 6. So that is the last one. Questions? It's not difficult, but you have to be careful. All the times, select to update, select and update. Questions? Any questions? Okay, I will consider it's okay. خلاص. So the user algorithm is a greedy algorithm. Make choices that currently seems the best. Locally optimal does not always means globally optimal. So if you think that, Allah, it's very clear now, I can reach from a city to a city. From any city to any city, that is the best. Not necessary. Not necessary. Sometimes it will be costly. It will be costly. So if I go, for example, from A to B, that is 2. Then I go to E, that is 10. So that is 12. where I can go to D, then go to the E. That is much better. So all the time you will find the shortest path from city to other cities. For every known vertex in the city, recorded distance is shortest distance. So that vertex from source, vertex here from the source. Be careful here. Okay, all the time. That number from the source. That number from the source, and so on, and so on. For every unknown vertex, its recorded distance is shortest path distance to V from source vertex, considering only currently known indices. طبعا في rarely to find that case if there is city not connected to the others. يعني مثلا look at C الآن. شايف C? Look at C. C is connected to A and F. طيب now can I go from C مثلا to A? Yes, I can. Yes, I can. Can I go from A to C? No, you cannot. So I have to take الباث اللي هو D and C. So it will take 1 and 2. So there are some cases if there is no things or there is, but there is a better one. These two cases he will take care about them. Last for today, minimum spanning tree. In the minimum spanning tree, three connected directed cyclic graph. Spanning tree, subgraph of a graph. It is subgraph of a graph. So you have a graph. All of these are graph. Then you will draw spanning tree. That is a subgraph. So you will not, or you will eliminate some of the edges. طبعا هي in a way or another similar to this one. Similar to the digester in a way or another. Okay, so which needs constraints to be three connected as cyclic. مهمة جدا هذه الcyclic. Okay, and connects every هذه will make difference between minimum spanning tree and a digester. Connects every vertex of the original graph. Minimum spanning tree with a weight less than or equal to any other spanning tree for a given graph. But it's not necessary for one to all. It's not necessary. Not necessary. Okay, let's see what is called Kruskal algorithm. هذا last for today, inshallah. Work with edges rather than nodes. 2 steps. Sort, very important. Sort edges by increasing edge weight. Select the first V-1 edges that do not generate cycle. It has to be a cycle. Okay, forget about any cycle might happen. Kruskal algorithm to find the minimum cost spanning tree uses a greedy approach. This algorithm treats the graph as a forest, and every node it has an individual tree. Tree connects another only and only if it has the least cost, minimum, along available options. Let's start. Again, you have a graph. Now you will calculate the minimum spanning tree. Rules. First rule, step 1, very important. Remove all loops. Do we have a loops? Yes, we have. That is a loop. Remove it. Remove the loop. Forget about it. And parallel edges. If you go back to the definition of parallel edges, it's like that, EUG. So we have parallel. Remove that one. طبعا remove the biggest, the bigger. Okay? Keep the smaller. خلاص. Now, after removing the loop, after removing the parallel, now my tree looks like that one. Next, sort the edges by increasing edge weight. Sort the edges by increasing edge weight. What is the smallest one? The smallest one is 1. That is from DE. So DE is 1. Is there any other ones? No. Next, what is the second smallest one? 2, which is from D to G. So from D to G is 2. Any other 2? No. 3. You will notice that we have several 3s. That is 3, that is 3, that is 3, that is 3. You can select any one of them. So now, EG, that is 3. CD, that is 3. GH, that is 3. Okay. And last one, CF, that is 3. CF, that is 3. So far, so good. Just select the shortest, the least, then go in increasing order. Next, no more 3s, no. What is next? 4. Again, we have several 4s. We have several 4s. You will do the same. So now you added 4. What is next? 5. We have only one 5. Only one 5. So you will select 5. AH. Okay, AH is 5. So that's the only 5. We have only one 6. You will add it. No 7s. Next, 1 8. 1 10. No 9s. So you will do that in that way. So far, easy? I think it's easy. Questions? Next. Now, you will add the edge which has the least weight, which is 1. And it is the only one actually. And it is the first one. So which is DE. That is the least one. You added that one. Okay, now let's see. Can we also add that one? We'll see. Yes, we can. So it is added. Okay, it is added. Can we add that one? No. Reason. That one will make a cycle. If you add EG, that will make a cycle. And one of the conditions, no cycles. No cycles. One of the conditions, no cycles. Avoid cycles. فين احنا قريناها؟ somewhere هنا أعتقد. والله نسيت فين قرأتها أنا. أحد فاكر؟ anyone؟ No cycles.
فالستيب 1 يا دكتور انه ما يكون في لوب.
Step 1. Yeah, remove. لا, loops هذه. That's the loops. No, I'm talking about cycle. Cycle that you are connecting D وG وE. So that is cycle مغلقة. اللوب no. اللوب في cycle أعوذ بالله من الشيطان الرجيم أنا قاريها متأكد منها. شرحتها حتى قلت لكم no cycles. هذا cyclic تمام. بس في ماكينه هنا ذكرت هنا مره ثانيه more than no using شايفين that select that do not generate a cycle. Anything that do not generate a cycle. So that one will هنا no cycle. DE ما في cycle. Now you added DG no cycle. If you added EG that will be cycle. So forget about it. That would create a cycle. So don't select it. Next, can I add CD? Yalla. Yes, no. Can I add CD, that one? Yes, no. Can I add CD? That one. Can I add CD? Yes, no. Can I add CD? Hello?
No one is sure.
طيب ما في مشكلة يا جماعة، يعني ماني شايل قلم واسجل درجات. هو انسر هنا. اوكي. طبعا I cannot عفوا I can add it because if I add C that one will not make a cycle. هي الآن it's already ordered, so don't worry about the numbers. Worry if it is going to make a cycle or not. That's the only thing. Okay, so now if I add CD, now I have GD or ED or DGDE, ما في مشكلة. So if I add that one, that will not make a cycle. So it is added. شايفين في cycle ما في cycle. Cycle it means will close. Can I add GH? Cycle. Look at it. Is GH هنا شايفينها؟ GH will make a cycle. يعني if أعمل خط أحمر هنا, is it going to make a cycle? No. So it will be added. شايفين؟ Now it's not closed. هذا the most important thing. It's not cycle. Do not generate a cycle. CF. If I add CF, going to make a cycle? If I add BC, is it going to make a cycle? BC. If I add BE, is it going to make a cycle? BE. BE. طبعا it's very clear. Yes, it will. Because هنا عندي DC, CB. So BE will make a cycle. So don't select that one. BE بعدين ED. So it is a cycle. Connected. Next, BF. Next, BH. Next, AH. See now, AH will be selected. هذه A وهذه H selected. So no cycle. اللون الأحمر هو الcycle. So it's not selected. DF, AB, AF, all of them will make a cycle. So that is the minimum spanning. It looks like a subgraph of the graph. You selected the lowest. You selected the lowest. That is the idea of the minimum spanning tree. Any questions? So it is done. خلاص ما عندنا. تفضل.
The table will be given, right?
No.
We have only to fill the...
No. You will, طبعا it depends on, لكن in case it's not given هنا انت you are starting here right here صح؟ Actually remove all that and we build your that. لكن الidea هنا that one هي exactly even if it's not given because you have to do it yourself, so you will start from the lowest. انت regardless ايوه 1. So that is the lowest one. So that's one. طبعا انت في يعني in the exam or anywhere, okay, you can say that is selected. خلاص forget about it. 1. So by the time you will start 2, 3, you will start until you reach to all of them. Anyone selected, خلاص say that one is selected. 3, 3, 3, 3, 3 selected. And then just search, is there a cycle or there is no cycle? Cycle, no cycle. Okay, طبعا هنا بس since we are done, that is the difference now between the two. Time complexity of digestera is V square, where the time complexity of coruscal is E log E. or you can say also E log V اللي هي edges والvertices. الedges والvertices هذا الفرق ما بين الاثنين. If you don't have any questions, any comments, any things you want to share with me, that is the end of today's tutorial. Questions? Any questions?